Welcome, Jim, to the IoT For All Podcast. Thanks for being here this week.
Thank you for having me on. It's great to be here.
Yeah, it's great to finally have you on. Looking forward to this conversation. And to kick things off, maybe it'd be good if you could do a quick introduction about yourself and the company for our audience.
So my name's Jim Morrish. I'm half of the founding partners of a company called Transforma Insights. We're a firm of industry analysts, and we focus on digital transformation. And within digital transformation, particularly IoT, connectivity for IoT, and AI, and a focus very recently, or quite a significant focus recently, in fact, has been AIoT, the convergence of AI and IoT, which I expect you're going to ask me more about.
No, I appreciate that. I mean, our audience is very familiar with Matt. He's been on many, many times. So it's good to have the other side of the company on. And yes, AIoT, very interesting conversation I think we could have. We haven't dove into this too much recently. So maybe for our audience, we could just high level a little bit. How do you define AIoT and how does it kind of differ from the traditional IoT M2M conversation?
There are different definitions of AIoT, and we're going to go for the fairly pure, fairly specific definition. So just starting off at that top level, some folks regard AIoT as just AI applied to IoT data. And the thing with that is that can happen anywhere. It can happen in the cloud. It can happen as part of the IoT application, which is associated with the device and why that device was deployed, or it can happen to exhaust data, etc. That's a very general definition of AIoT, which you will see some in the market using. What we mean when we talk about AIoT is AI deployed on board the IoT devices. So that's a much more specific and tight, pure definition of AIoT. And that unlocks a whole range of benefits, because effectively what you're doing is you're moving compute power closer to the data, closer to the information, and those AI analyses much closer to the source information, and it unlocks a whole series of benefits. Firstly, you've got improved performance. The responsiveness of applications can be much quicker. Imagine a self-driving Tesla, which has to communicate all its camera and LiDAR information to the cloud and have it analyzed and sent back again. It just wouldn't work. That has to be AI on board the device. And the same thing applies across many other applications. It's many of those less extreme situations than the car, but it's just better, quicker, faster, more reactive, responsive to have the processing locally. And then there's a range of other benefits: compliance, privacy, security, and reduced costs.
That's fantastic. And I know you've been in the space kind of for a while. Early days M2M has turned into IoT. And so how's the terminology just in general and the market understanding kind of evolved from when you kind of got into the space, or maybe just even before, if anything you've researched, kind of looked into, all the way up until now? Things have evolved. I mean, I've been in it pretty much since, I guess, IoT, and now it's kind of transition. But just talk to us through how the terminology has evolved and why that's been a kind of a natural progression of the industry.
I can spin back to one before IoT. So you may be aware, or your listeners may be aware, that Matt and I co-founded a company called Makina Research back in 2011. And in those days, it was M2M, not IoT. And in fact, we put IoT on our business cards, and we had questions from people who said, interoperability testing, why do you do that? So since then, IoT is somewhat caught on. I don't think AIoT is something that displaces IoT. It's a subset. It is for deployment in certain situations where it unlocks significant benefits. I'll take another example. So something like a smart speaker. So one implementation of that, the device could be listening to everything that you say, and it could scoot it off the cloud and analyze it and generate responses. Privacy, security issues associated with that. So having the AI on board the device gets around a lot of that, because you've got the processing locally, and then anonymized requests are sent to the cloud to procure whatever data, weather information, or whatever it is. It's an enhancement and a subset of IoT rather than a substitute for it.
And how big would you say the AIoT market opportunity really is? What's really driving adoption now for that subset that we're talking about?
Well, it's big. So again, I'll start off with at a very high level. By 2034, we reckon that about a quarter of IoT devices will have AI on board and thus be AIoT. Now, as ever, the same rules apply to AIoT as apply to IoT, which is that the size of the addressable market tends to dictate the device count. So you've got a lot of things in there, which are things like smart speakers and connected TVs and cars and so on. And those tend to get penetrated quite quickly. What's more interesting is the long tail of enterprise applications that are things like exception detection, anomaly detection, or deploying AI on board a CCTV camera. And you can put that kind of a solution in many, many situations to detect all sorts of things that do happen or things that don't happen, or people who go to places they shouldn't be, or that are not wearing things that they should be, like PPE and hard hats on a building site.
If you were to talk us through, and you kind of just already hinted at a few there, but just what are some of the more compelling use cases where AI is truly transforming IoT developments today? Maybe if there's, well, some that were kind of you've seen deployed, and then when they layered on the AIT side, just kind of took it to a whole new level.
The AI use cases that really drive adoption are things like natural language processing, chatbots and digital assistants, and image processing and analysis. But the thing to be careful with, or the thing that's interesting there, is you might think image processing and analysis. Well, fine, you find that in a CCTV camera, obviously. But you might also find it supporting gesture control in a vehicle, or mood analysis of somebody who's a driver in a vehicle, or gesture control for a television, etc. So you can find these AI use cases distributed across a lot of different devices. In terms of the actual device count, it's things like AV equipment, vehicle head unit, personal portable electronics, CCTV, personal assistance robots, all those little robot vacuum cleaners and robot lawnmowers and so on. A very long tail of very diverse scenario-specific applications, much as IoT is.
Yeah, that's fantastic. Yeah, I was going to ask you kind of where you've seen from a device standpoint, which devices are really leading the way with this kind of edge intelligence. So we've talked about edge computing for quite a while, but it really seems like that's coming into play more and more with the AIoT. So, edge AI basically really contributes to AIoT success. So, cameras, like you said, certain robotics and things like that are leading the way. I guess maybe if you could touch on a little bit more the benefits of being able to do that compute at the edge, what that enables organizations, or maybe the use cases to kind of achieve versus what they were able to do before.
From an organizational perspective, I mean, a lot of it comes down to the much tighter and closer monitoring either of processes or devices or assets. So, for instance, things like preemptive maintenance, or much better in-depth monitoring of machinery, building site machinery, those kind of things. Looking at a specific deployment of something like an image analytics. I mean, you could have a CCTV camera with an AI engine on board it, which you point at a production line, looking at the quality of, say, printed circuit boards as they come off that production line. And it could learn to recognize where there are errors or imperfections in those things that are being produced, and learn what it is that's causing those. If there's a problem upstream in the production line, obviously the learnings from one site, and this would probably be guided learning, because you might have a technician there who says this type of problem is caused by this type of error in a machine up the stream, which could then be shared with other cameras in other factories performing similar things. So really quite diverse, and it's kind of like IoT on steroids in many ways.
Now, if we talk about the cellular, or sorry, not cellular, the connectivity side of IoT, which is obviously a very big topic, right? You have cellular, satellite operators, you name it, all different types. What does AIoT mean for kind of the connectivity piece? Are these connectivity companies, are they just the service providers, are they just becoming enablers, or will they play a more strategic role in AIoT?
So if you just look at the connectivity piece in terms of the just moving bits of data around, then on average, if you take an IoT device and then that same device in that same scenario, same use case, you deploy an AI engine on board it, you're probably going to be sending less data to the cloud. So compare, for example, an IoT CCTV camera looking at cars, versus a automatic number plate recognition camera, which actually identifies what the number plate is and just sends the number plate, as opposed to the video stream. Much less data. So you get that redaction of data, and more refined information sent back. What that means, or what that unlocks, is potential to deploy those devices in places where the business case wouldn't previously have stacked up because the connectivity costs are too high. So you get probably on an individual device less traffic, but more devices cost in. So that's the first thing. But the next interesting one is around the management of those devices. Because because one of the key things about AI is the homogeneity of the operating environment. So you need to be much tighter in terms of the device management and ensuring that the software versions and the operating systems that that device is running are all consistent across the estate. And thus, when you deploy the AI engine onto those devices, it operates in exactly the same way on each one of them. You also need more insight into the configuration of the devices, things like even things like the battery condition and the detail of the BOM and the SBOM, just so that you can understand if you're getting some odd results from your AI deployed in a certain state of devices, is that something that's caused by just the specific devices that it had, the boards on board that they're using or something like that. So you need much more insight into the estate.
And are there any new techniques, technologies, capabilities that are needed to support AIoT, like based on coming from IoT into layering that on AI? Are there new kind of anything that we need to be kind of thinking about here as opposed to like a standard piece deployment?
There's a series of things, in fact. We've evolved to a situation where we have a stack of IoT platforms that can support IoT devices. We're also developing a set of tools that support the AI environment. Now, the thing is that the IoT stack tends to be optimized for constrained devices that don't change too much and are relatively simple. And the AI's tools tend to be configured for engines or AI analytics that are deployed in unconstrained devices. And when you bring those two things together, you have a whole range of new problems. So the first thing you need to do is take the AI models, which might work brilliantly in the cloud, and specify those and shrink those and compress them so that they work on an AIoT device, resource constrained, power constrained, possibly connectivity constrained as well. And then what you've got to do is you've got to monitor those the results that are coming off that device, monitored for wandering and things like that. Now, again, in the cloud environment, that's easy to do because you have unlimited bandwidth, nearly unlimited power. You can really closely monitor the processes that are going on in the cloud. If it's a remote device which is connected via a cellular connection, it's much harder to analyze exactly what the software is doing, what the inputs it's getting, what the outputs generating are, and whether they're consistent across a device estate. And you might also get evolutions in different device estates. So, for example, if you have, spinning back to our CCTV example, if you've got a CCTV example where you recognize individuals in say the summer, and it's deployed in a stadium, a sports stadium, and an airport. If you move into winter and suddenly the ability of those solutions to detect people carrying heavy bags deteriorates, well, that's not an issue in an airport because you expect people to be carrying heavy bags. It's a big issue in a sports venue because you don't expect people to be carrying heavy bags there, and you really need to identify when they are because they might be doing something that you want to know about and stop. So you get so the effects of drift can be different across different device estates depending on the context they're deployed into. And things like this are complicated to manage in a bandwidth and power constrained environment.
How does this all kind of factor in on the hardware side? Any trends that are worth noting, especially around maybe the chipsets, just how is this all evolving to support AIoT? Any are there any standout innovations or companies really focused on building for AIoT? I guess I should say.
It's a very different environment to a cloud environment. Yeah, cloud environment is the focus is basically in the most processing power for the least amount of waste heat. It really is what the equation comes down to. Now, with an AIoT environment, you've really got there's much more of a focus on chipsets and systems on chip or configurations of chip that are really optimized for the functions that they are performing. So, for instance, what I come as sort of regarded as leader in this space, SEMA AI. They develop systems on a chip, which are for image recognition. And they have APIs, a platform, etc., to help develop the applications. And their view is that if they de-skill the development of the applications, they'll sell more chipsets. And yeah, but those are constrained chipsets optimized for those particular situations. And there's a range of other companies, there's the likes of Halo and Accelera and Untether AI and Mythic and so on, who are developing chipsets optimized for different scenarios and different situations. So the AIoT chipset and hardware market is kind of much more fragmented and interesting and innovative than the cloud market. I should add, though, that the market for cloud AI, as exemplified by NVIDIA, is much bigger. But this smaller AIoT market is actually very interesting.
One of the challenges that we've seen over the years since we've been involved in the space, kind of one of the reasons IoT for All was ever created, was just getting people to understand what IoT is, right? And now we have AIoT. So, how are you seeing companies, or I guess maybe just an industry as a whole, how do we cut through the noise, set realistic expectations for what's happening, where we're going, when we're going to get there, kind of thing? Because I know very early on, analysts would set expectations for the IoT space, and it maybe took a little longer to get to certain stages than some people originally thought. So how do we how do we approach things with AIoT given its relatively new base that it's kind of created for itself?
I agree. The M2M/IoT space has been on a long journey from being a specific technology to just part of the enterprise toolkit, and it's still not there yet. It's getting close, but people just need to regard it as a way of deploying the application that they want, and it happens to be a device that's connected, which is remote and to the core systems of the company. The thing with AIoT is not really a new message to communicate. Think of that smart speaker example I gave with the AI on board, so you don't have to send the streams of audio to the cloud and back. That's transparent to the end user. It's just a better way of doing it. Once people have got over the concept of IoT and the fact that devices can be connected and can do these things, well, the AIoT is just a better way of doing it. I don't think it needs to be sold as a technology or positioned as a technology in the same way that IoT had to be called out and then has to be sort of absorbed into the enterprise toolkit. I think that AIoT is just a more natural progression.
One of the questions I guess that's worth noting, or just maybe bringing up here, is what lessons from maybe the early days of M2M and IoT are still relevant as we navigate AIoT, as it's growing? Are there anything that kind of carries over that's important for people to kind of really think about?
It's all about use cases and optimization. And I think that is probably more extreme in the case of AIoT than it was in IoT. So always, people I think used to regard the IoT market as a huge thing. And yes, we'll go out and sell IoT, and you don't sell IoT, you sell a solution or you sell a use case. And the devices and the solution needs to be optimized for the use case. I think that concept carries forward to AIoT and is sharper and more specific. There is more optimization to be done for a specific use case. The lesson that goes forward is it is a fragmented market. The devices and solutions have to be developed and deployed one by one effectively.
One last thing I want to ask you before I let you go here is, if we look ahead, what's one of the things the industry needs to really get right in the next year and a half to truly capitalize on AIoT?
The management of devices and the management, particularly of SBOM on board devices and the BOM and tracking that BOM. So it's getting really good information on that. The other thing is regulations. I think a lot of regulators are taking an interest in AI. Some of it's all well intentioned. I think some of it's a bit misguided. I think some of it needs correcting. And I think that we as a society are going to have to think of what it is we want AI to do and how we want it to do it and how we want to govern it. I think a lot of the early approaches to AI were, people would trot out and say it needs to be fair. It's impossible to be fair. It's been proven that it is impossible to be fair in many situations. It can't be done. What you can aim to do is be as good as humanity has managed to achieve so far, and possibly improve a little bit beyond that. But getting to something that's provably fair is impossible. And we need to have those discussions and understand the situations in which we're going to deploy AI and how we're going to manage it and risks and liabilities that will be associated with that.
For our audience who wants to learn more about what you all have going on, stay up to date with all the content you put out, the reports, everything, what's the best way to do that? And is there anything kind of on the kind of coming up shortly that we should be on the lookout for?
I would say to folks, scoot over to transformainsights.com. That's our website. We have a free subscription option. If you're a subscriber, you can see all of the content I've been talking through and more. But we do have a free option which does allow access to at least the AIoT forecast report, which is built in some very granular analysis. So head over, you can download that. We give it away for free. And many of the things I've spoken about, there's high level summaries of them available on our blog. And we also have a focus page, a focus topic page on AIoT on our website, which is available to all.
Yeah, we'll make sure we link that up. It's great, great resource. But thanks again for taking the time to do this again. And tell Matt we said hi. Always love talking to him as well. So we'll have him on sometime again.
He's off in Svalbard at the moment, would you believe? So he's escaped the heat. It's chasing iceberg.
Yeah, we'll have to touch base because we've done some pretty good like quarterly updates with him in the past, and it'd be great to have him back on. So thank you so much. This is a great conversation. Excited to get this out to our audience, and hopefully we'll talk again very soon.
Thank you very much for your time. It's been great to be a guest.